and it was primarily guesswork. You might have gotten something close, but never an exact answer. Differentiation enables you to calculate it precisely by considering the gradient between 2 points with an infinitesimally small distance between them. To do this, let's remind ourselves of the gradient formula. The change in y divided by the change in x. Now we'll rewrite this formula slightly differently. We'll call the first coordinate x and f of x, and the second coordinate x plus h and f of x plus h. Substituting these into the gradient formula gives f of x plus h minus f of x, all divided by h. This setup is useful because h represents the small distance between the 2 points. By changing h, we can control how close the points are. For differentiation, we want the most exact form of the gradient, so we let h get as close to 0 as possible. However, setting h to 0 would cause division by 0, which we cannot do. To resolve this, we use the concept of a limit, written as the limit as h tends to 0. This allows us to calculate the gradient without breaking mathematical laws. This is the definition of differentiation, often called differentiation from first principles. For example, let's differentiate f of x equals x squared from first principles. Start with the formula. Substitute f of x plus h as x plus h squared. For f of x equals x squared, the formula becomes x plus h squared minus x squared, all divided by h. Expand the numerator to get x squared plus 2xh plus h squared minus x squared. Cancel out the x squared terms. Simplify by dividing each term by h. Finally, take the limit as h tends to 0, which gives 2x. So the derivative of x squared is 2x. Now, is there a quicker way to do this? Let's take a generic term, x to the power of n. Using the same approach, we substitute f of x plus h into the formula and expand x plus h to the power of n, using the binomial expansion. When we simplify, the xn terms and the terms involving h cancel out as h tends to 0, leaving n times x to the power of n minus 1. This is called the power rule. To differentiate, multiply by the current power, then subtract 1 from the power. For example, if f of x equals x squared, the derivative is 2x. If f of x equals 2 times x to the power of 4, the derivative is 8x to the power of 3.